Hello, my name is Alvaro Macias Fernandez, and I'm a PhD student at the University du Quebec at Ormar. My research focuses on the design of fuel cell hybrid configuration for electric vehicles. This project is under the supervision of Professor Loic Boulon from UQTR and Professor João Pedro Trovao from the University of Sherbrooke. As we know, greenhouse gases are one of the main causes of global warming, and one of the most promising solutions to this fossil fuel dependency are electric vehicles. In line with this, my project consists of the design and power supply system for the Can-Am Spider electric vehicle platform located at the University of Sherbrooke, for which the main challenges during the design process were the high dynamic profile, low mass, and compact layout requirements. From there, I chose the fuel cell system as the primary power source due to the high energy density and fast refilling time compared to the batteries. Additionally, a supercap bank is included to operate as a low-pass filter. This will lead to high energy efficiency and longer lifetime of the fuel cell. With this objective in mind, my first step was a literature review to evaluate the different hybrid configuration with a SWOT analysis. Secondly, I simulated the vehicle powertrain and power supply submodels. And thirdly, an optimal sizing method was integrated to evaluate the performance of the passive, semi-active, and full-active architectures. Here, you can see the result for a high-speed real driving profile in which the passive configuration reaches the lowest trip cost, representing a 6% reduction compared to the others, but this architecture deteriorates more the fuel cell. It is observed that in the full active configuration, the energy management strategy avoids an unnecessary on-off cycle, because this configuration is able to use the complete supercap state of charge range. Also, from the current distribution perspective, we can observe that the full active and semi-active configuration operates in current above the maximum efficiency point, while the passive structure works in the complete range since there is no control over the fuel cell. Based on these results, the passive architecture might be an interesting configuration to be implemented in fuel cell hybrid electric vehicles. This work is the first in its class to propose fuel cell as a power supply system for motorcycle to reduce the CO2 emission and increase the range compared to the battery vehicles. In addition, the developed step sizing method is compatible with any nonlinear multi-objective cost function of a hybrid vehicle system. And, as a product of this research work, 2 journal articles have been published. Thank you for your attention.